Pluto and the possible ninth planet beyond Neptune. 1. Introduction to Pluto. Pluto is one of the most famous objects in our solar system. It is located in the distant Kuiper Belt, a large region beyond the orbit of Neptune, containing millions of icy objects left over from the formation of the solar system. Pluto was discovered in 1930 by American astronomer Clyde Tombaugh. For many decades, scientists classified Pluto as the ninth planet of our solar system. School children around the world learned that there were 9 planets, with Pluto being the most distant one. However, Pluto is very different from the 8 major planets. It is extremely small compared with Earth and the other planets. Pluto has a diameter of about 2,377 kilometers, making it smaller than Earth's moon. Pluto is also extremely far from the Sun. Because it receives very little sunlight, its surface is extraordinarily cold. Despite its small size and distance, spacecraft observations have shown that Pluto is a surprisingly complicated world, with mountains, plains, glaciers, an atmosphere, and several moons. So, Pluto is not simply a small frozen rock. It is a fascinating planetary world that has helped scientists understand the outer solar system. 2. Why Pluto was reclassified as a dwarf planet. For many years, Pluto was officially considered a planet. The situation changed as astronomers discovered more objects in the outer solar system. Scientists began finding objects in the Kuiper Belt that were similar to Pluto. One particularly important discovery was Eris, an object roughly comparable in size to Pluto. This created a problem for astronomers. If Pluto was a planet, should Eris also be called a planet? And if Eris was a planet, what about other large objects that might eventually be discovered? To solve this problem, the International Astronomical Union, IAU, established a formal definition of a planet in 2006. Under that definition, a solar system planet must orbit the Sun, have enough mass for its gravity to make it approximately round, and have cleared most other objects from its orbital neighborhood. Pluto meets the first 2 requirements, but it does not meet the third. It shares its distant orbital environment with many other Kuiper Belt objects. Therefore, the IAU classified Pluto as a dwarf planet in 2006. This did not mean Pluto disappeared or became less scientifically interesting. It simply received a different classification. A useful way to understand this is, a planet dominates its orbital neighborhood. A dwarf planet is round because of its gravity, but does not dominate or clear its orbital neighborhood. Pluto is therefore still a major object of scientific interest, even though it is not one of the 8 major planets. Pluto is located beyond Neptune in a region called the Kuiper Belt. The Kuiper Belt can be imagined as a huge, thick disk or donut-shaped region surrounding the outer solar system. It contains countless icy bodies and remnants from the early formation of our planetary system. Neptune orbits the Sun at an average distance of about 30 astronomical units. 1 AU is the average distance between Earth and the Sun. The main Kuiper Belt extends roughly from around Neptune's orbit outward to about 50 AU, although objects can be found much farther away. Pluto is one of the best-known objects in this distant region. Pluto's orbit is also unusual compared with the relatively orderly orbits of the 8 major planets. Its orbit is elliptical, meaning it is not a perfect circle. It is tilted relative to the main plane of the planetary orbits, and extremely long, taking about 248 Earth years to complete one trip around the Sun. Because Pluto's orbit is so large, a person born on Pluto would have to wait almost 248 Earth years before celebrating their first Pluto birthday. This distant location is also important because it is one reason Pluto became part of the debate over how planets should be classified. One of the biggest surprises from NASA's New Horizons mission was how geologically interesting Pluto actually is. Before New Horizons reached Pluto, scientists had only distant observations of the dwarf planet. They knew very little about its surface. That changed dramatically in 2015. New Horizons showed that Pluto has mountains made largely of water ice. Because temperatures are so low, water ice behaves more like solid rock does on Earth. Pluto has plains. One of Pluto's most famous regions is a huge bright area called Sputnik Planitia. It is part of the larger heart-shaped feature known as Tombaugh Regio. Pluto has glaciers. Pluto has large areas of frozen nitrogen and other ices. These materials can move slowly across the surface, producing glacier-like activity. Pluto also has craters. Like many other planetary bodies, Pluto has impact craters created when objects collided with its surface. Pluto also has a thin atmosphere. It contains gases including nitrogen, methane, and carbon monoxide. The atmosphere changes as Pluto moves closer to and farther from the Sun during its long orbit. These discoveries changed scientists' understanding of Pluto. Instead of being a simple frozen ball at the edge of the solar system, Pluto turned out to be an active and complex world. Pluto has 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon is by far the largest. It is so large compared with Pluto that scientists often describe Pluto and Charon as a particularly unusual pair. NASA's New Horizons spacecraft provided humanity's first close-up examination of Pluto. The spacecraft launched in January 2006 and traveled through space for approximately 9.5 years. On July 14, 2015, New Horizons flew past Pluto. It came within approximately 12,500 kilometers, about 7,800 miles, of Pluto's surface, and collected enormous amounts of scientific information. The spacecraft gave scientists detailed information about Pluto's surface, mountains and valleys, ice formations, atmosphere, moons, geological activity, and surface composition. New Horizons then continued into the Kuiper Belt. In 2019, it also flew past Arrokoth, another distant Kuiper Belt object. This mission was extremely important because it transformed Pluto from a distant point of light into a real world that scientists could study in detail. Is there another planet beyond Neptune? This is the most important part when discussing a new planet. Scientists have proposed that a large planet could exist far beyond Neptune. It is commonly called Planet 9 or Planet X. However, it has not been directly observed and confirmed. The idea comes partly from the unusual orbital behavior of some distant objects in the outer solar system. Scientists noticed that certain distant objects appeared to have orbital characteristics that could potentially be explained by the gravitational influence of a much larger unseen object. Imagine several small boats in the ocean, all being influenced by the gravity of something enormous that you cannot see. By studying the boat's movements, you might infer that something large is affecting them. In a similar way, astronomers study the orbits of distant solar system objects. The proposed Planet 9 could potentially have several times Earth's mass, a very distant orbit, a highly elongated orbital path, an orbital period of thousands or perhaps tens of thousands of years. NASA explains that the proposed planet remains theoretical and that astronomers have not actually observed the planet itself. So we must distinguish between evidence suggesting a planet might exist and confirmation that the planet has actually been discovered. Why finding Planet 9 would be important? If astronomers eventually discover Planet 9, it would be one of the most important discoveries in modern planetary science. Why? Because it could tell us much more about how our solar system formed. The solar system began about 4.6 billion years ago from a huge cloud of gas and dust. Over time, gravity caused material to come together and eventually form the sun, planets, moons, asteroids, and other objects. Scientists have computer models describing this process, but the distant outer solar system still contains many mysteries. A confirmed Planet 9 could help explain why some distant objects have unusual orbital patterns. It could also provide evidence about the early movement of the giant planets. Perhaps a large planet formed closer to the Sun and was later pushed outward by gravitational interactions with Jupiter, Saturn, Uranus, and Neptune. That is one reason scientists are interested in searching for it. But there is an important scientific rule. A hypothesis is not the same thing as a confirmed discovery. At present, the evidence for Planet 9 is indirect. NASA continues to describe the proposed planet as hypothetical. Therefore, headlines saying NASA confirms a new planet beyond Neptune should be treated cautiously, unless they are supported by an official NASA announcement describing an actual observational discovery. 8. Conclusion: Pluto, Planet 9, and the future of astronomy. The story of Pluto demonstrates how scientific knowledge changes as new evidence becomes available. For decades, Pluto was considered the ninth planet. In 2006, scientists changed its classification to dwarf planet after astronomers gained a better understanding of the many objects occupying the outer solar system. But Pluto's reclassification did not make it unimportant. The New Horizons mission showed that Pluto has a complex surface, mountains, glaciers, and atmosphere. The mission also demonstrated how much remains to be discovered in the distant Kuiper Belt. At the same time, astronomers continue searching for possible worlds beyond Neptune. The proposed Planet 9 could be a large planet hidden in the extremely distant outer solar system. Scientists have found intriguing indirect evidence, particularly unusual orbital patterns among distant objects. However, NASA has not confirmed Planet 9 as a real observed planet. Therefore, the scientifically accurate conclusion is, Pluto is a confirmed dwarf planet, not a newly confirmed ninth planet. A possible ninth planet beyond Neptune remains an exciting scientific hypothesis, awaiting direct observational evidence.